We're going to look at an example from CSET 213, number 23, and it's asking for what value does this series x minus 3 raised to the nth power divided by n times 4 raised to the nth power converge. And our options are x equals -1, x is less than 7, and these two, which is x is greater than -1 and less than 7, or D, x is greater than -1, less than 7. Alright. So we're going to use the ratio test. And the ratio test says if we let m goes to infinity of an plus 1 an, if it is less than 1, it converges. Absolutely. Therefore, converges. If it's equal to 1, if the limit n goes to infinity an plus 1 an equals 1, then it's inconclusive. If it's greater than 1, it diverges. Okay. So let's put this to the test. I'm going to copy it. So that's an. An plus 1 equals n equals 1, x minus 3, n plus 1, n plus 1, times 4, n plus 1. So let's do the ratio. Limit n goes to infinity of an plus 1, an equals x. I'm going to write a different color. Plus 1 equals x minus 3 n plus 1 divided by n plus 2 times 4 n plus 2. I'm going to pick another color. An times x minus 3 n times n plus 1 for n plus 1. I'm going to bring those same terms together. So it's going to be x minus 3 n plus 1 divided by x minus 3 n plus 1 n plus 2. This one's still on. Times. Okay. This one's gone. This one's gone. Did this one. 4 n plus 1 divided by 4 n plus 2, which is equal to x minus 3 n x minus 3 x minus 3 and these two cancel out. Plus 1 and plus 2, leave that as is. 4 n plus 1, 4n plus 1 times 4 here. These two cancel out, which is equal to x minus 3 n plus 1 n plus 2 divided by 4. Limit go to infinity. It's going to be 1 divided by 1. It's going to be 1/4. So we use L'Hopital's rule on this. So it's going to be x minus 3, 1, 1 times 1 and 4. That's x minus 3 divided by 4. L. X minus 3 less than 4. So let's draw on the number line. Negative 3, negative 4, negative 5, negative 6, negative 7, negative 2, negative 1, 0, 1. 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so that's our radius of convergence right here, and we're not sure what happens at negative 7 or 1. So our answer is between C and D, which is negative 1 or so we just need to check for 1 for this one. So let's plug it in Sx to our series. So if what happens when x equals negative 1? So it's negative 4 n and 4n equals negative 1 n 4n n 4n, which equals negative 1 n divided by n. Does this, if it's this, it then diverges, but it's not that. It's an alternate series. Okay, so I looked at the answer sheet, and supposedly if this converges, that's because 1 decreases absolutely, and 2, it's alternating. Therefore, it converges. So therefore -1 x 7 is a radius of convergence. I didn't know that. I thought I knew that. I'll do a wrap up of this. This was actually a little bit harder than I thought. So the first thing you need to know is the ratio test, which I have here. So if it's here's a ratio test. If it's less than 1, it converges. If it's 1, you don't know, it's conclusive. If it's greater than 1, it diverges. And from there, from the algebra, you had to know that if an alternating series, where's that? This series, if it's alternating and it's decreasing absolutely, then it converges. And thank you for watching.